A digital twin is a highly complex virtual model that serves as an exact counterpart, or twin, of a physical object. Process or system. It is not just a static 3D model or a basic blueprint. What makes a digital twin unique is that it is a living, evolving digital entity. It uses sensors on the physical object to gather real-time data, which is then fed back into the digital model. This allows the digital twin to reflect the exact current state of its physical counterpart. Here's a detailed breakdown of how they work, why they are used, and real-world examples. How a digital twin works. The architecture of a digital twin relies on three main pillars. The physical entity, the real-world object or process, like a wind turbine, a car, or an entire manufacturing plant. The virtual entity, the digital representation residing in a computer system or the cloud, and the data link, the flow of information that connects the two. The physical object is outfitted with various IoT or Internet of Things sensors that measure metrics like temperature, vibration, energy output, and stress. This data is constantly transmitted to the virtual entity. Once the virtual model has this real-time data, it uses artificial intelligence, machine learning, and advanced analytics to run simulations. It can predict how the physical object will perform in the future, identify potential failures before they happen, and test how different conditions might affect it, all without risking the actual physical asset. Real-world examples. 1. Aerospace and jet engines. Companies like GE Aerospace and Rolls-Royce create digital twins of the jet engines they manufacture. Every time a plane flies, sensors on the physical engine send terabytes of data back to the digital twin. The benefit: the digital twin analyzes this data to predict exactly when a specific part will wear out. Instead of grounding a plane for routine maintenance, airlines can perform predictive maintenance, saving millions in downtime. 2. Urban planning and smart cities. Entire cities are now utilizing digital twin technology to improve urban living. Singapore, for example, has Virtual Singapore, a dynamic 3D city model and collaborative data platform. It incorporates data on demographics, movement, and climate. The benefit: city planners can simulate how building a new skyscraper will affect wind patterns, how a new subway line will shift traffic congestion, or how the city's power grid will handle a severe heat wave. 3. Formula One racing. In F1, fractions of a second matter, and testing physical cars on real tracks is strictly limited. Teams like Mercedes and Red Bull build incredibly detailed digital twins of their race cars. During a race, hundreds of sensors on the real car transmit data back to the team's headquarters. The benefit: the team runs thousands of simulations on the digital twin during the race to test different pit stop strategies, tire wear scenarios, and aerodynamic adjustments, instantly relaying the best strategy back to the driver. 4. Healthcare and the human body. While still emerging, the medical industry is moving toward creating digital twins of human organs. By inputting a specific patient's MRI scans, ECG data, and blood pressure, doctors create a highly personalized model. The benefit: a surgeon can test different pacemaker settings or simulate a complex surgery on the digital heart first, ensuring they choose the safest, most effective approach for the real patient. Why are digital twins important? Risk-free testing. You can test extreme scenarios like a hurricane hitting an offshore oil rig digitally without risk. Cost reduction. By shifting to predictive maintenance, companies save vast amounts of money and reduce equipment downtime. Faster innovation. Engineers can design, test, and iterate entirely in the digital space before manufacturing a single physical prototype. For software-related courses online training, please contact VLR Venkat at +91 9059868766. Thank you for watching.